Pinnunciator is a complete system for enhancing the lighting of your pinball machine or other equipment. With 6 channels for LED strips or servo motors and up to 9 inputs for triggering effects, the Pinnunciator allows you to seamlessly manipulate various types of LED strips, servo motors, and other high-powered digital devices like a shaker motor or pinball coil without writing a single line of code. Some of the most obvious uses for the Pinnunciator in pinball machines are adding left and right side blades along the edges of the playfield, adding LED strips to the left and right sides of the apron, backbox effects, individual lighting of toys or other playfield elements. Evolution Mods sells plug-and-play LED strips of various sizes to accommodate all of these requirements. Other practical uses for the Pinnunciator are add a physical knocker, add a custom shaker motor, add a custom toy using a servo motor, a Christmas tree. We're constantly finding new uses for the Pinnunciator. We can't wait to hear what ideas others come up with. Included with the Pinnunciator is the Light Show Studio software. This software unleashes your creativity by providing a way for you to easily customize the behavior of your connected devices without writing a single line of code. Adjust brightness, speed, color, and many other parameters with precision, allowing you to fine-tune your creations effortlessly. The Pinnunciator truly empowers you to turn your creative visions into reality. Is it really that easy? And how does it work? First, let me explain the hardware. The Pinnunciator board requires 12 volts of DC power. Power can be applied via the 2-pin JST connector or wired into the screw terminal from any source. Ensure that your power supply is not producing any more than about 12.1 volts of DC. Power supplies are available from Evolution Mods that are plug and play if desired. There are 6 LED ports on the Pinnunciator board. WS2811 or WS2815 compatible LED strips can be connected to each channel. These are 12-volt strips. The main difference between WS2811 and WS2815 strips is that for WS2811, there are typically 3 LEDs per addressable position. With WS2815, every single LED is addressable. We have found that WS2811 strips are best for most applications on pinball machines. We have selected 12-volt strips because they are ideal to minimize voltage drop in your equipment. Do not connect 5-volt LED strips to these ports. 5-volt strips, such as WS2812, would most likely work if proper 5-volt power is applied to the strip. The 6 LED ports also double as pulse width modulation or PWM ports that can be used to control up to 6 servo motors simultaneously. Most servo motors require 5 volts DC, so Evolution Mods has produced a small adapter board to allow you to easily connect a 5-volt power source to drive the servo motor. In addition to servo motors, any PWM compliant device can be controlled via these 6 LED ports. Additionally, you will notice 3 RJ45 ports. These allow you to connect up to 3 I/O boards. Each I/O board has an LED port that you can connect an LED strip to. These LED ports are shared with LED ports 1, 2, or 3 on the Pinnunciator board, depending if the I/O board is plugged into port 1, 2, or 3. This allows you to easily mount LED strips in various locations within your equipment. The Pinnunciator software allows you to individually control sections of LED strips too. So you always have the option to daisy chain multiple LED strips together and address those sections individually by specifying the LED segments to control in the software. This gives you the ability to connect multiple LED strips to a single channel and control all aspects of that strip if needed. Each I/O board has a high power digital output that can be turned on or off. If you had 3 I/O boards connected to the Pinnunciator, you would have 3 high-power digital outputs available. You can connect a separate power supply with appropriate voltage to power the device you have connected to the digital output, or, assuming your device requires 12 volt DC and requires less than about 1 amp of current, you can use the 12 volt power from the Pinnunciator. If your device draws more than 1 amp, we recommend using a separate power supply for your device. All I/O boards have the same features. The only difference is the type of signal accepted by the inputs. Each I/O board has 3 inputs, so connecting 3 I/O boards will give you a total of 9 inputs to work with. There are different I/O boards available depending on what type of input you are looking to trigger your effects with. There's a photoresistor or switch I/O board. This is our most popular I/O board. It allows you to connect isolated switches or photoresistors for triggering your attached devices. You can place a photoresistor next to any light source and trigger your effects without any physical connection to your equipment. This is the safest and least intrusive way of integrating with your equipment. Next, we have the low voltage I/O board with common ground. The 3 inputs on this I/O board will trigger when an electrical signal between about 2.7 to 5 volts is applied. Do not connect anything higher than 5 volts to these inputs. Then we have the high voltage I/O board with common ground. The 3 inputs on this I/O board will trigger when an electrical signal between about 4.7 volts to 60 volts DC is applied. Do not connect any higher than 60 volts for these inputs. This I/O board assumes a common ground, so it will likely not work for things like pinball coils, but will work for other high voltage devices that do share a common ground. Finally, we have the high voltage I/O board with uncommon ground. This board is ideal for pinball coils, where switching occurs on the ground side of the circuit. Most coils are wired up this way. The 3 inputs on this I/O board will trigger when an electrical signal between about 1.5 volts and 60 volts is applied. The I/O boards can be placed anywhere in your equipment by using standard Cat6 RJ45 cables of any length desired. We recommend Cat6 due to the thicker wire specifications. You can mix and match I/O boards. For example, you can plug in a low voltage I/O board into port 1 and photoresistor or switch I/O board into port 2, which would give you 3 low voltage inputs and 3 photoresistor or switch inputs. Programming the Pinnunciator is as simple as connecting a USB cable and clicking the program button. An optional Bluetooth module allows you to program the Pinnunciator wirelessly via Bluetooth. I've just given you an overview of the Pinnunciator hardware. Now, let's take a look at the Lightshow Studio software that will make customizing your solution super easy. I'm going to be giving you a very brief demo. There will be some other videos that get into some more detail, but this should give you an idea of what the Pinnunciator is capable of. I thought I'd start by just setting up a very simple project. Let's set up something where input 1 will trigger this LED strip on channel 1. On channel 1 we have a WS2811 LED strip with 6 segments on it. So I'm going to first configure input 1, which it's basically already configured. I just gave it a name. You can set the polarity, which means that you can reverse the behavior of that input, and it is enabled. Channel 1, we need to make sure that we set the output type to GRB because this is a GRB strip. Now, when purchasing LED strips, it's hard to tell whether they're GRB, RGB, or BRG. Sometimes you just have to buy them and try them out. Now we need to specify the number of segments. There are 6 segments in this LED strip, 6 segments of 3 LEDs each. Next, we need to go to our Patterns and Rules tab. So let's create a very simple pattern. I'm even going to call it red. And we're going to do a single color pattern for all segments. And I'm going to select the red color. And I'm going to now add a rule. The rule is going to be flash channel 1. You can call it whatever you want. Here is where we determine our triggers. We need to specify an on trigger and an off trigger. The on trigger is when we want our rule to turn on, and the off trigger is when we want our rule to turn off. So under on trigger, I'm going to select based on trigger immediately. Now we can edit our on inputs and set my first input to active. Click OK. Now we need to specify when the rule should be turned off. So I'm going to select based on trigger immediately, meaning it's going to be based on the on trigger that we just selected. When that on trigger goes off, then the rule will turn off. Now we need to say where do we want to send the pattern. We want to send it to channel 1. What effect do we want to apply to that pattern? Let's just do something simple, just a solid effect. And the pattern for the effect is the pattern we just created, which is red. I'm going to click OK, and we're done. It's all configured. Now all I have to do is click Program Board and test it. We got a flashlight. I'm going to shine some light. As you can see, light now activates the pattern. Now what if we want a different effect? Let's change that effect to a strobe effect. Very simple. Set it to strobe. You can set the effect speed, slow it down a little bit maybe, and then click Program Board. Now let's test it. We have our effect. One more effect change. We can try pulsating. Program Board. Now we're pulsating. Very simple. We can change the color by going to the color palette. If we want to change all instances of this red, we could change it here, or we can go into the pattern and change the color for the pattern. We can even rename the pattern. And program and test. We've got our green. Very quick and simple. This system is multi-threaded, so you can create as many rules as you want, and all the rules will run simultaneously. Now, to show you something a little bit more complicated, I'm going to open up a demo that I created earlier. Now, this one is running all these rules simultaneously, including servo motor rules. So we have 3 servo motor rules. Just to give you an idea, I'm going to open this up and I can set the position for the servo motor. So in this case it's going to go to position 600, and then it's going to move to position 2500, and then it's going to move to 600. And our triggers are set up to have some time delays on them. They're very easy to configure. We are also daisy chaining some rules together, so when another rule ends, then the other rules start. We're kind of creating a little infinite loop here. You can also see that we have all these different effects going out to various output channels. We have a gradient pattern here that's being used for channel 4. A scrolling pattern here. We're going to scroll these colors. And let's just program this and see what it does.